Alrighty, so here we go again. This week we're going to kind of dig a little bit into some new stuff, talking about new ways that we can describe graphs. Remember that there are going to be 2 copies of these notes posted. There'll be a blank copy and there'll be a filled in copy. So you can decide whether you want to write as we go or if you want to focus more on listening. That's up to you. You're also welcome to pause as we go if you need to take a little bit more time. But yeah, let's get started. So remember last time what we were talking about here are functions or relations. So they're anything that's connecting a set of numbers. So your set of numbers are all of your data points, right? What is my speed at 5 minutes? What is my speed at 10 minutes? Those are all the data that we are trying to connect. And when we look at that, we have 2 very different data points. We have the numbers that go in, which we call the input. These are our x values. So these are often things like time, things that are consistent and set in motion, whereas things that are our outputs, so the numbers that come out, depend on whatever our input is. So our y value, your speed, depends on how long you've been driving. The height of your plants depends on how long it's been growing for, right? So your outputs or your values depend on those x values. So for example, if we've been just looking at this function x plus 2. The input is what we put in, right? So let's say that we were dealing with an input of 1. When we put that 1 in for x, we get the number 3, right? 1 plus 2 is 3. That is our output. Right, so our function is the relationship between x and y. And so last day we were talking about different ways that we can represent graphs. So we had those table of values. Remember, with our x being on the left and our y being on the right. Input, output. And so for the most part, because we have no better information, we've just been guessing which numbers go in here, right? And same with for our output. Well, we know the relationship that would help us determine that output. Mapping diagrams are very similar, right? We've got x on the left and we've got y on the right. The difference here is in a table of values, we list all of our values. In a mapping diagram, we don't repeat numbers. So for our x's, we have -2, we've got -1, 0, 1, 2. For my y's, I've got 1. Now I have 2 2's. When I transfer that into a mapping diagram, I'm only going to write it once. And then I have 3 and I have 5. The way that we show these 2 2's is with the arrows, because the arrows show the connection between the x and the y, which x values are related to which y values. So that -2 goes with 3, so we would draw an arrow. -1 goes with 2, so we draw an arrow. 0 also goes with 2, so we draw an arrow. 1 goes with 1, and 2 goes with 5. So the arrows show you which values are connected. We also have ordered pairs. Similar to a table of values, these show all of our values. Remember, your ordered pairs are always going to be x on the left, y on the right. So I would have a -2 and a 3. I would have a -1 and a 2. 0 and 2, 1 and 1, and 2 and 5. So these are all of the points that are in my graph. So if I was graphing this, I would have a point at 0 and 2. I would have a point at -2 and 3. I would have a point at 1 and 1. I would have a point at 2 and 5. I would have... These are all my points. Oh, 0. -1 and 2. Right, so this would be the graph. Graphs can also look like solid lines with arrows. They can look like solid lines with endpoints, right? These are different types of graphs. What do they all have in common? They all represent the data. right? There are different ways, but they all kind of mean the same thing. They're all talking about the graph. But the question here is, with these data points, how can I tell if I should be using a graph like this or a graph like this? Because remember, or how do you know what data points to plug in? So up until now, when we were trying to build a table of values, we were guessing, right? Kind of trying to evenly space them on either side of 0, but we didn't really know whether or not those points were valid. Because remember, when we were talking about discrete and continuous graphs, depending on the data that we're using, sometimes it makes sense to connect those dots. So for example, if we were growing something, right? It's growing in between our data points. We're just not collecting that data, but it exists. Whereas sometimes we don't connect those dots because that data doesn't make sense. So for example, you can't have a half of a person, right? You can't sell a half of a ticket. So here it doesn't make sense to have the data in between tickets because you can't sell them. So how would we know if those dots are connected or not? We need to know more about our graph. And sometimes that can come from knowing the scenario, right? If we know what the X and Y values are, like if they're time or speed or tickets, shoe sizes, right? Then we can kind of logically figure that out. Or what we're going to talk about today is you can know the domain and range. And those are two things that will give you more information. We can't guess because not all graphs will include all points. Right? If you're in a plane crash, you can only go to the ground. You can't go into the negative numbers, and that's an important thing to know about. So I just brought up these words, domain and range. So what do they mean? So what they do is they tell us which X and Y values are possible. They tell us the set of numbers that work, the set of numbers that are in our graph. And just like X and Y, independent, domain is talking about the input, which remember were our X values, and range is talking about the output, which is our Y values. So it's important to remember which is which, because if you do them backwards, your graph is going to look different. We use this set notations. Remember I said that X and Y are talking about a set of numbers. We have a special symbol that shows that we are talking about a set of numbers. And the set symbols are these fancy brackets. So we would say domain could be anything, and I'm using dots for the numbers, but pretend that there are numbers in there, within that data set. And we could also say that range could be any number in this data set. Right, so we use that set notation. So this is a set of numbers. Now remember, when I'm talking about domain, I'm talking about input. And for convention's sake, we're always going to go from lowest to highest for both domain and range. So if I'm looking at my input, which remember are my X values, those are always in a point going to be on the left. So I've got this one. So an important thing to note, just like in a mapping diagram with domain and range, numbers don't repeat. So we're just going to write the numbers once. So here, when I'm talking about domain, remember we say domain can be, and we're going to say in this set of numbers. So I have a 2, Then I have another 2. Now, because I don't repeat, I'm not going to write the second 2. I only write it once. Then I have a 5. That's all of the numbers that are included in this set. So it has to be one of those numbers. We can't have any other numbers because they're not included in my data set. Now for my range, that's my output, which are my y values. So those are going to be on the right. So we've got 1, 2, 3. And we're going to try to write these in smallest to biggest order. When we're dealing with points, it doesn't make the biggest difference, but it's a good habit to get into for when we get to lines, when it does matter. So for my range, it's going to go, this -3 is going to come first because that's the smallest number, it can be part of. We have a 5 and we have a 7. And those are all of the possible numbers, so we can close off that set. We're not going to be declaring whether things are functions or not today. So we're going to go back to another number set. So once again, domain, remember, is my x's. So those are the numbers on the left. And we're going to go from smallest to biggest. So I'm going to start with the 6. So remember, can be part of this number set. 6, 7, 8. And we're going to close off the set. Those are all of the numbers that are in my graph. You'll notice that even in the question, they use the set notation to show that these are all of the numbers that are on my graph. So same with range. I've got 1, 2, 3. So we're going to start with the smallest number. So 5, 5, 2. 2 is going to be my smallest number. Then I have 5. Now here, I have 2 5s, but I only need to write it once. Because just by writing it once, you're saying 5 is a possibility. You don't need to say how many times that number shows up. It's kind of irrelevant. So graphs are very similar, right? We know our points. When I'm dealing with domain, I need to talk about my x's. So with domain, I'm moving along my x-axis, and I'm going to move from the left, right, from here, along my x-axis. I'm going to do red again, actually, just to be consistent. So domain is my x's, right? Remember, this is your x-axis. So we're going to start at the left, and we're going to move to the right, because we always want to go from smallest to biggest. So I'm starting, and as I move along my x, I check my line. Do I have any points? Nope. What about here? Yes, I have a point. So this is going to be part of my domain. So if I count, that's 1, 2, 3. So if I'm looking at my domain, -3 is a possible value. And then I keep going to my next line. If I look here, do I have a point? Yes. So that means this is part of my data set. So -2 can also be a number. And you keep going, right? Nope. Nope. Yep, this one's on there. So that means 1 can also be part of my data set. Nope. Yep. So 3 is also part of my data set. And that is all of the possible numbers. And then I'm going to do the same thing for range. Now remember, I'm going to go smallest to biggest. So I'm going to start for range, which is my y's, at the bottom and move up to the top. So I'm starting at the bottom. Nope. Oh, part of the data set. Nope. Yes. 1, 2, 3. So that's -3. Now notice that I have 2 points on that line, but because in range I only need to note it once. Just by saying it once, I'm saying it's a possibility. It doesn't matter how many times that data point shows up. And then we're going to keep moving up. Nope, nope, nope. Yes. So 1 is a possibility, and 2 is a possibility. We're not doing functions today. Okay? So once again, we're going to start with my domain, which is my x's, from left to right. And as I move along, do I see any points? Yes. Does it matter that there are 2 points on here? No, I only need to write that one number once. So domain is part of my data set. -2 is one of them. No, yes. So there's another point, right? That point falls on that x-axis. So that's going to be a 1 and a 2. And for range, I'm doing the same thing. I'm going to start at the bottom and I'm going to move up. Right? Domain, we're going to stick in a range. And so I'm looking at each point as I move up. Do I have any points there? Oh, yep, I have one here. Once again, it doesn't matter that there are two. We only write it once. 1, 2, 3. So it's -3. And then moving up. No, 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 yes. So 2 is on there. And yes, 3 is on there. Okay? So that's any time that we have a set of points. Notice that we have a set of points in my domain and range because there's only very distinctive points that are part of my data set. The number in between those points doesn't matter because it can't be in my graph. But what about something like this? If I'm looking at my domain, remember when we were looking at domain, we're going from left to right. Right? So I'm going to start here and I'm going to go this way. So we start here at -1, 2, 1, 2, 3. Now as I move over, every point as I move over is hitting this line. And remember that I can only see like a -2.9, -2.8, but the numbers in between there also count. So -9 or 2.81, 2.82, 2.83. It would take me forever to try and write all those numbers out, right? -1, -0, 1, 2, 3. How long do I have? 1, 4, 5. And for my range, the same thing. When I hit here, that 1, I'm just going to erase these so we can see. And we're going to move up, right? So I hit this -1, and it also touches at -2, and it also touches at -3, and it also touches at -4, or +4. Oh, what am I doing? All these are positive. And 5. But the problem with doing a list like this is when we have a line, remember every single data point between those are also part of the data set. So just listing them is not a complete data set. So how can we show that? How can I show that every single number is included? We use what's called range notation. So now instead of having a list of numbers, we're going to show the range. So if you notice, check here, same graph. Okay, so we're going to swing down because it's the same graph here. So if you notice that if I'm looking at my x's, right, so I'm moving this way, I have this point and this point, and they kind of make a line sandwich, right? My line is in between that sandwich. What I can do is use these greater than or less thans. Because what this means is if I put my smallest number here, so 1, 2, 3, -3, and my biggest number, 1, 2, 3, 4, 5, over here, what this shows is x is any number that's in between, right? Because this is in the middle of the sandwich. Any number that's in between -3 and 5, because it says -3 is smaller than x, and 5 is bigger than x, but x is everything in between. And what's really important, you'll notice the difference between these two graphs is that this graph has dots that are colored in, and this one has an open. We need to show that -3 and 5 are part of the data set. We do that by drawing a little line underneath. So this says -3 is smaller than, but also equal to. It's a part of that data set. And 5 is bigger than, but it's also equal to. So that little line underneath there shows that. And so for range, we do the same thing, except this time we're dealing with the y-axis. So we're going to start at the bottom, and we're going to move up. So as I go, I hit a point right here, and I hit a point right here. Those are making my line sandwich. At the bottom of my line sandwich is a 1, and at the top is a 5. And because those dots are filled in, they have to be a part of the data set. So I add a little equal sign in there, right? 1 is smaller than y, but it's also equal to, it's a part of that data set. And that's going to be different than this line over here, because if we look at this line, when I do my my line sandwich, the line doesn't actually hit that point, right? Because that's open, it's showing me that the data isn't actually hitting that point. It's not part of my data set, it's a limit. So when I'm drawing my -3, I'm not going to put that equal sign because that -3 is not part of the data set. But my 5 on the upper hand is, because it's colored in. So it gets a line, but the -3 doesn't. And we can do the same thing with our range. So we're going to start at the bottom and we're going to move up, right? We're starting at the bottom and hit a point, and I hit a point. And I make my little line sandwich. At the bottom there, I have the 1. And because it's colored in, it's part of my data, right? 1 is smaller, but it's also part of it. It's equal to. At the top, at that, what was it, 5? It's open. So that 5 is not a part of it. So it does not get a line underneath. Okay, so domain and range are almost like there are barriers. Like if we were to take our line and put it in a box, where would that box sit? So this time we have a circle. But remember that it's the same thing. What we're looking for is that line sandwich, the box that goes around my graph. Sorry, I was checking something. So if I'm looking at the domain, I'm looking at my x, right? So I'm moving this way. So it looks like I hit this point and I hit this point. So there's my line sandwich. So on the smaller end, I have 1, 2, 3, 4, 5, 6, 7, -7. And because the line goes right up and it touches that point, I'm going to say that that -7 is part of the data set. And on the big end, 1, 2, 3, 4, 5, 6, also part of the data set. And with my range, same thing. Bottom, remember starting at the bottom, moving to the top, looking for where that line hits. So I've got a -2, that's part of the data set, and I've got a +2, that's part. Okay, we're not doing functions today. So we're going to look at a couple of these. So we've got a triangle, so we're going to start with domain. So remember, domain, smallest to biggest, right? So I see a line here, and I see a line here. And remember, it doesn't matter how many times the line touches that point. It's still my limit. I don't need to write it 5, 6 times. I only need to write it once. So for A, domain is going to be between -3, and because that line goes right on top of there, it's going to be a part of the data set, 2, 3. Once again, it touches, so it's going to be a part of the data set, and that's my whole data set. Oops. Oh my goodness. Back. Right, and for range, so do we see that anywhere? Yeah, we don't have to do range, we see it right here. So that's okay, we're going to do range anyways. So range, bottom, and top, right? That's where it hits, so our range is going to be -2, and it's going to be part of the data set. And we're going to use the same arrows every single time. They're both going to be smaller on the right, bigger on the left. But this time we're dealing with y because we're talking about range. Oh, we don't know if it's equal to yet. And at the high end, I've got a 4. And because that 4 touches, it's going to be equal to. So that's going to be this guy right here. Okay, so for B, we're going to deal with our domain. Okay, so on the small end here, it looks like I've got a -4. So we're going to have domain -4. And because it touches, it's going to be part of that data set. And on the big end here, I've got a 3. Notice that this ends in 2 spots. It ends here and it ends here. But we're looking for the furthest point. So even though there's 2 endpoints, we're choosing the furthest point. And because it's open, that 3 is not part of it. So it's not going to get a number underneath. Now, usually we have to check and be careful anytime that you see a circle in the middle of your line, because this would indicate that -2 is not a part of your data set. But because when we look up here for -2, there is a line, that -2 is included because it is possible, just not in this location, right? But you can always, if there's a number that's left out like this, that doesn't have a point going through it, you can always just say that x can't equal 2, let's say. But in this case, because there's another one, it is included. So do we have that? -4 and 3? Yeah, up here, so this is going to be easy. And we'll try C. So we can do that for our range as well. So in this case, let's do our range here, sorry. So we're going to, oh my God. So we're going to start at the bottom, and we're going to move to the top. So at our lowest point there, we've got a -5. Oops, range. Make that a little bit nicer. And because that's an open dot, that's not going to be a part of our data set. And we're dealing with y because we're looking at range, and we're going to go up to 5. And once again, open dot, not a part of our data set. And that's what we see here with no lines, because those are not a part of the data set. I just want to add an open circle here just to show you guys something. So let's pretend that that's an open circle. Actually, here, I'll even make it black. So there's a question, what do you do if there's an open circle in the middle of your line? So we're going to start with our domain. So the 2 extremes, right? So my 2 extremes are -5. And because that's an open circle, it's not part of my data set. For right now, we're going to ignore this circle because we want to encompass the whole line, and it goes up to a +5. But this time that's closed, so that's going to be a part of my data set. But we have to be careful here with this open dot, because all of those data sets are true except for this -1. That -1 is not part of the data set because this is an open dot. So how do we show that? Well, we can just say domain equals -5 to 5, but x cannot equal -1, right? We just include that, put a comma after your set as part of the domain. So x can equal any number from -5 to 5, but it can't equal -1. That's like an exception to the rule. And when we're talking about range, we're going to go from here to here. And once again, remember that what we're looking for is the lowest point. So for my range here, my lowest point is a -2. Now, is that -2 part of the graph? Because we have an open circle here. But if we look along that data point, because remember, we're talking about any point on -2, I've got a couple of spots here where the graph does touch -2. So it's actually included in the data set, even though one spot doesn't work. Because as long as it shows up anywhere, we show it. And at my tallest here, I have a 2. Once again, we've got that open point, but because it hits at other points, that is a part of my data set. So I don't have to put that exception in when it comes to the range, which would make that D. Okay, so for our last example, we're going to start with our range, or domain, sorry. So remember, domain, we're starting at the smallest, going to the biggest, and we're going to hit the furthest points. So we've got 1, 2, 3, 4, 5, 6, 7, negative 7. And once again, because that's open, we're not adding a line under. And then on the top end, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that goes right up into that point, so we're going to include that. And we do our bottom of our graph, right there, to the highest point on our graph up there. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. And that touches at negative 9, so it's a part of my data set. And we're going to go all the way up to 1, 2, 3, 4, 5, 6, 7. Once again, touches that point, so it's part of my data set. So even though this open is here, because if I trace along, we see that it does hit at some point, we don't have to include it in our data set, right? If there was no other point there, we would need to make that exception. What if we filled in the point? Hold on, I'll change color so we can see this. What if I filled in this point? What would that do? Well, if we filled in this point, that would change my domain, because here we said that it was not part of the data set. But if it's filled in, now it is a part of the data set. Right? So those are two different scenarios, and so it's important to be aware of them. So you guys are going to have one IXL topic today, or this week, and then you're going to have a worksheet to go along with it as well. So if you go on IXL, you should be suggested to do J2, which will be your IXL for this week. It focuses more on discrete graphs, so single points, whereas when we're looking at lines, that's going to be found in the worksheet, which will be posted under your assignments. So if you have any questions, remember, I'm free every day from 10 to 11 and from 1 to 2, and you can just find me on Zoom.